Hi guys, in this video we'll be discussing the problem A greatest convex from code forces round 842 division 2. I'm sure most of you would already have solved the problem, but I'm not sure how many of you actually know the logic behind it. I'm pretty sure that a lot of people actually just saw that the answer would always be n minus 1 and they just printed it out. But it's always good to know that why it's coming so and why it's always valid. So in this video I'll be discussing the approach, the mathematics involved for this. So with that, let's get started. So the problem states that you are given an integer k. Find the largest integer x where x is less than or greater than or equal to 1 and is strictly less than k, such that x factorial plus x minus 1 factorial is a multiple of k, or determine that no such x exists. Then they have given us the basic definition of a factorial, and they have defined what a multiple basically means. So we definitely know that, so I'd be skipping that part. Then they have told us that the number of test cases or t is less than or equal to 10 to the power 5, and the k, that is the number they have provided us with, is less than or equal to 10 to the power 9. So we are not interested in that, because anyway the answer is going to come in order of 1, so it could be anything and we still would be have been able to process that. So we just have to print a single integer, that is x, and that is the answer for us. So with that, let's get started. So what they've said is that they'll be giving us an integer k, and then we have to give them an answer x, such that x factorial plus x minus 1 factorial is a multiple of k. And if number, like more than one number more than one answer exists, then we have to give the biggest value of x. Over here x is also strictly less than k, so this is something that is crucial and you need to remember. So when we expand this particular theorem, so what we can particular term, so what we can say is x factorial is x into x minus 1 into x minus 2 up to so on to 1 plus x minus 1, so we are now expanding this, so plus x minus 1 into x minus 2 up to so on to 1, right? So now when we'll do it, so like solve it further, so we can say that this term is actually common. So let's write down this common term into, now x would be from here and 1 would be from here, into x plus 1. So that's the term we are getting. So if I can also write it down as x plus 1, and this is x minus 1 factorial, so it is x plus 1 into x minus 1 factorial. This is the final answer we get if we select x as a term. Now what if x is equal to, the maximum value for x would have been x is equal to k minus 1, because we cannot have x is equal to k, as they specifically mentioned that x is less than k. So the maximum value for x we could have gotten is like x is equal to k minus 1. Now let's try to use that. What if x is equal to k minus 1? So let's try to put k minus 1 in the term, so it becomes k minus 1 plus 1 into k minus 1 minus 1 factorial. This would turn out to be k into k minus 2 factorial. Now we are multiplying this term by k, so that means this entire term is a multiple of k. That's exactly what we need. So that's the proof that our answer for any k would simply be x minus 1, would be k minus 1. The code, if you want to see it, it's not required actually, because it's actually pretty easy, but if you still want to see the code itself, so here's the code for this. In the code we are doing nothing, but we are just taking n and then printing out n minus 1. That would always give you the AC solution. Yeah, that's it guys for this video. Although this question was really easy, I hope I was able to make you understand the maths behind it, and if you still have any doubts, let me know. Thanks a lot guys.